awesome. You know, it's the worst part. But it's not really a bad part. It's a blessing. But I'm not a organized type of person. So one of the biggest stresses is going to Boomer Book and like replying to all my friends, relatives, and family. You know, like and try not to miss anybody because if you miss somebody, then like
The great man is really good.
yeah, my mom's like, so you didn't reply to my message, my post yet. I'm just a human. So. All right. Thank you guys for the birthday love. It's very sweet. 48 years old today. I started teaching here at UL right out of college at Auburn. I was 29 years old. And so approaching 20 years, and it goes quick. It goes quick. So do me a solid. I've never even asked this, but we were asked to do it. Whether you like my teaching style, whether you don't, usually you hear more from the people that don't. It's all good. But the teacher evaluations are up and available. So take some time, give me some feedback. I appreciate it. Usually I only get like 3 replies a semester, and they're pitchforks and torches. So sunshines and rainbows would be appreciated this year. Our last exam is going to be Wednesday, Friday, December 6th. Guys, I know it's unconventional, but my intent with the optional final is if you have a grade that you're comfortable with, I'm not going to take it and go spend that time on other tests. In the past, students struggled on my final, but it wasn't because it was the materials, because you got other stuff. It's the end of the semester, you're tired, you got all these other things. And so one of the ways I'm trying to help you, help me, and kind of put you in a position to make those grades or those plays is to say, I'm not going to offer you double jeopardy unless you need it or want it. So in other words, after 3 tests, I'm tested you on all the material that I feel is important to put you in a position for my next class that I teach. So you're going to average out your 3 grades. Just use Moodle for your grades, but just do a quick average. You add up your 3 scores, you divide by 3. So I keep it simple. If you do come and take the final, it's cumulative, but I promise you I'm not going to like randomly pull obscure facts. It's going to be a general, it's basically, hey, show me you know a little bit from the first test, the second test, and third test. And hopefully you do well on kind of retaking stuff that you've already had, learned from, and feel comfortable with. And then you would have 4 exams if you take the final. And so you add up those 4 and you divide by 4. No foolies, no complex multipliers, just averages. Cool. And then on top of that, I try to help you even more by setting the threshold, because I understand this class is a little different. I don't make you buy a book, which I think is helpful. You know, now, good Lord, school's already ridiculously expensive. But I understand that my teaching style is a little different. So to try to help, I set the threshold of a C at 65. So I'm trying. Help me help you. Speaking of helping me help you, how about we open it up for questions, clarifications? Remember, I can't answer, will I? But I can definitely answer, can I? Or if you need me to clarify something, or if you need me to go over something again, no problem at all. But the kind of questions of, will you do something? I haven't written it yet. I don't know if I'm going to do it or not. Can you ask this? Or is this a fair question? Or that's totally fair game.
Do examples. I know I struggled on the last steps, but I need to know it for.
Okay. So,
like.
Yeah, no problem. So I think the first thing, so the question is, can we do hip examples? And absolutely we can. But I think before we do examples, I think it's important to go over hip motion, just to make sure we're not making a mistake before we even get That's what the muscles, right? We gotta make sure we know the different motions. So hip flexion, I'm gonna have flexion pullers. Hip extension, I'm gonna have extension pullers. Abduction, I'm gonna have abduction pullers. Adduction, I'm gonna have adduction pullers. The illusion for the hip is this is external and this is internal.
That's what my scramble was.
So I'm gonna have external pullers and I'm gonna have internal pullers. I'm gonna put the camera down a little bit, so I don't think you quite saw the foot. So we have external rotation pullers and we have internal rotation pullers. So again, the motions, it's not like I'm gonna test you on motion directly, but we still have to know motions. Yeah, or you're already kind of behind the eight ball, right? So we need to make sure we understand our motion, our illusionary motions. So for a hip question, it could be, what muscles of my left hip hold in this position? My abductors. What muscles of my right hip are helping me hold this position? Abductors. Yeah. Like if I relax my right hip muscles, bang, I'm going to have left lateral or right hip adduction. So I need abductors to hold that position. I'm doing a stork stand or weight bearing on my right leg. I need my abductors. Abductors concentric, abductors eccentric. Left hip flexors concentric, left hip flexors eccentric. Left hip extensors concentric, left hip extensors eccentric. Hip rotators, this would be external rotators concentric, because from here I have more mass on the inside. Gravity is trying to internally rotate me, right? So I have to use my external rotators concentric and then my external rotators eccentric. Yeah. But I think that's a really good way to start class, because the motions are important so that we can identify the agonist pull. But if you're still getting confused that this is shoulder flexion and you think it's shoulder extension, you're already going to kind of be behind the eight ball of getting the agonist. It's a good way to lead off. Thank you. Did that clarify that? Can you say that one more time? Upper body motion. So the question is upper body motions. I'm gonna do it I'm not gonna go as fast as I can, but I will kind of go at a pace so that, it doesn't take up too much time. So feel free to say, stop right there. Can you go over? So in other words, as I do it, be like, okay, I got that, I got that, I got that. Hey, can you go with this? Okay. We'll start distally. Remember, what do all, what's that? Yeah, absolutely, absolutely. Absolutely. The question was, can I move up a little bit? Absolutely. No, I need that feedback. Oh gosh, where was I? Vertical dinosaurs came. Yeah. Thank you. So remember, flexions and extensions get you in the fetal and out of fetal, right? That's why we have so many different joints have those same names. So we'll start distally. Finger flexion, finger extension gets you in the fetal, out of fetal. Wrist flexion, wrist extension gets you in the fetal, out of fetal. But remember, it's not about fingers going forward, fingers going back, because I could pronate and have wrist flexion where my fingers go back, extension, fingers go forward. Follow the fingers. That's my key word. Follow the fingers in the flexion. The wrist also has radial and ulnar deviation. To the pinky, to the thumb. To the wind, to the floor, to the wall. I forgot the words of this one. Pinky side, thumb side, ulnar radial. Okay. Radial on the joint, pronation, supination. Thumb rule. So remember, as I teach these things, it's all about local landmarks in the body, not global landmarks. Right? So far, so good? So radial ulnar joint, wrap, unwrap stuff, okay, elbow, fetal out of fetal, flexion, extension, okay. Shoulder follows the same rules as the hip. Flexion, extension, internal, external. The illusion is because the elbow gets you in the fetal anteriorly in anatomical, the knee gets you in the fetal posteriorly in anatomical. And when I flex both of them, you create this effect where the rotation is the exact same, but it looks different because as this part goes this way, the bottom part goes that way. But it's all about the rotation, not about the linearity. It's not about hand goes in, foot goes out. It's about spin. And so lateral rotation or external rotation is, hey, shoulder, rotate or spin laterally, just like we would say, hey, kid, spin to your right or to your left. Well, a side of a side, there is no right or left. It's the right of a right is the same structures in part as the left of my left. So both of them are lateral. So spin laterally or externally. So this would be shoulder and hip internal rotation. This would be shoulder and hip external rotation. Internal, external, it's the same spin. Scapula, elevation, depression, protraction, retraction. And then when the arms go up, whether that's sagittal or frontal, the scapula can help reposition the socket by upwardly or downwardly rotating. And that's it, unless I forgot something. Was there anything you need me to go over more in detail? Okay. So all of those motions have muscles that pull that way. Flexion pullers, extension pullers, ulnar deviation pullers, radial deviation pullers. There's as many different muscle groups as there are joint motions. So if we gave a joint motion, we got to have muscles that pull that way. Sure. So the question was, can I go over concentric and eccentric of the radial ulnar joint? Okay. Let me first preface it by saying muscles, skeletal muscles all are bound by the same laws and rules. There's no exceptions. In fact, the only difference between like cardiac muscle is that it's involuntary. You know, it happens on its own, but the structure is the same. Smooth muscle, the actin-myosin are like randomly inserted. So regardless of the length, you get like a consistent pull force, but skeletal muscles all follow the same. So concentric of my radial ulnar joint muscles follow the same laws as concentric of my ankle muscles or my elbow muscles or my wrist muscles. It's just different muscles pulling in different motions. Okay. So for my radial ulnar joint, we follow kind of the same pattern. Identifying an agonist. Who am I using? Because I'm asking myself, why do I need to use them? So if I have an external force at my radial ulnar joint and it's trying to pronate me, right? And I'm holding this pipe in this position, I do process of elimination. I try to identify who I do not need so that I could better have confidence of who I do need. So I'm asking myself, who would I not need to hold this pipe in this position while it's trying to pronate me? I don't need pronation muscles. And we're going to learn who those muscles are, but I could see I don't need muscles that pull this way. If I'm trying to hold it in this position, I need muscles that are pulling this way. I need supinators, supination pullers. If I'm holding this position, there's no motion, isometric. Why are the other contractions not consistent with same length work? I don't know. In there to name. I wish they were. But isometric is the easiest to identify. One, there's no motion. It's what we call static system. But the contraction makes sense. It's the muscles working above resting tone, and it's not changing length. It's doing a job. It's the elevator is stopped at floor 10 and letting you off, but that rope is still pulling up so that you don't fall down. Okay. I taught you this system to better see contraction, because contractions are confusing, because there's so many variables. There's motion variables, there's muscle variables, and then contraction variables. So what we try to do is we try to identify our agonist, the muscles that are pulling in specific directions of motion, doing a job. Once we have the agonist, then we can say, well, what motion did we observe, or did I tell you is happening? And with those two pieces of the equation, contraction is proven. It's solved for. There's no exceptions, because that's just law, that's physics. So if you know that in this position I'm using supinators, and supinators pull in the direction of supination, if I observe supination, the only way supinators do supination is through concentrics. And concentrics got its word from concentric circles. So if you're making a circle, like on a piece of paper, you're starting in one point and you're coming around to the other point. So it's like for concentrics, it's like bringing a point to the other point, shortening, trying to bring 2 points together. So supinators, when they're working, because you identify that they're working here, do supination through concentrics. Supinators are going to do pronation through eccentrics. Eccentrics got its name because it's weird. Eccentric, eccentric, it's not normal. A muscle pulling one way is responsible for motion the other way. It's like a curveball, like baseball, right? You're expecting fastball, and all of a sudden that changeup comes and you get fooled by it. So that's why we bring everything to agonist first. Then we say, well, what motion did we see for the contraction? So if I was here, I wouldn't need supinators anymore. I would need pronators, because the pipe's trying to supinate. So if I know I need pronators and I observe pronation, pronators, pronation, concentric. Pronators, supination, eccentric. So for a full range of motion, pronators concentric, pronators concentric, pronators concentric, supinators eccentric, supinators eccentric, supinators eccentric, supinators isometric, supinators concentric, supinators concentric, supinators concentric, pronators eccentric, pronators eccentric, pronators eccentric, pronators isometric, pronators concentric, pronators eccentric. But it's all about identifying the agonist first, and then looking at the motion as a function of that agonist to kind of see or prove or show contraction. And guys, this is my system. This is what I developed with my dyslexic brain, because it makes sense to me, because I don't like guessing. Like, I like knowing. And so that's what I try to teach, to break it down so that we can follow the path to contraction. Did that answer that question?
I was gonna. How would you ask the question about
The question is, how would I ask a question about plyometrics? If it wasn't my birthday, I would say I would ask it in English. But I think I've used that joke several times before. So I would ask, that is a very fair question. And I would ask it in layman's terms or in kinesiology terms, such as identify if I'm doing, let's say I'm doing 10 reps of this exercise, right? And it would be an exercise that I'd have a start to finish, or it would be something that I think we're all familiar with, right? just did radial joints, so just some on my mind. But I'm doing 10 reps, and I might say, would the plyometric sequence of my agonist muscles happen when the pipe is at its lowest point, or when the pipe is at its highest? What do you think? Absolutely. Because gravity could do that. But you know what gravity can't do? Slow it down as it goes down and speed it up coming up.
So can we use that as like a?
Absolutely. Yeah, absolutely. You could use it as a hint. Another hint that I gave you guys was, you know that the plyometric sequence is eccentric followed by concentric. Yeah, you take that table. I hope you learned your lesson. Coming up is concentric. True. So the top part is a transition of concentric to eccentric. It can't be that. It has to be eccentric to concentric. So where's that transition? The key thing is that it's not the entire way down followed by the entire way up. That's a repetition. It's specifically when you got to put on the brake with eccentric and then put on the gas. But yeah, there's all kinds of hints in there to help us identify. The reason that sequence is so important, though, is because damage. That's where your muscles are going to have the most damage. Phrase in the rope. The muscle has to work more than whatever weight it's doing in order to slow it down, then in order to speed it up. That's when the load on the muscle is the greatest. So I need to teach you guys to identify. It may not have practical use now, but it will. One day it will.
Now, we have an example of the contract where the contraction is isolation. It's just mentioned, I'm not sure. How would we go about answering a possible question existing?
About isometrics? I'm only speaking for myself. I would want me to ask 33 isometric questions.
Yeah, obviously, it's obviously the easiest one. Right?
Yeah.
And we really only talk about concentrated
Because those are the toughest ones. But we can do like when we did this one, like start off with isometric to establish what the external force is trying to do.
So that's isometric.
Because and this is how I know. If it was here,
Yeah.
There's no muscles in my radioulnar joint working isometric. It's muscle in my elbow, but gravity's not trying to do anything to my radioulnar joint. It's here. So the thought experiment for isometrics is if I turned all those muscles off, what would happen? So therefore it has to be working isometrically to maintain that position. Isometrics is when we did one of the first days of classes. This is just a reminder review, and this is also feedback for me. Maybe I need to do more of this. Remember when we did the manual muscle testing?
Oh, yeah.
That was all isometrics, because that's when I set the precedent that your body knows what to recruit because you know why you want to recruit it. So those first two classes were all about establishing the isometrics, where if I'm trying to push down, you need muscles that are pushing up. If I'm trying to push out, you need muscles that are trying to push in.
It's like I'm doing a manual person test.
Oh, absolutely. Absolutely. Yeah. I think in one of those first few classes that we did was like the head, right? Where someone's doing like a manual muscle test and they're pushing left ear, left shoulder. So you need muscles that are pulling right ear, right shoulder. External forces trying to extend you, you need muscles that are trying to flex you. External forces trying to flex you, you need muscles that are trying to stay. And those are all isometrics. But I also understand that was a long time. So sometimes we need those refreshers. I understand. It's a great question. But I think of all the different questions, the isometric ones are, let's say the easiest, but like there's not as many variables with motion. Also, I'm glad you brought that up because that reminds me, the one question that I said I would ask on the pelvic girdle rotations because of trunk was isometric. Remember the ones where I think it was the windshield wiper exercise? Yeah. Because that was tough because the pelvis and the trunk are working in opposition. And so I didn't want to put motion in there until we get to 415. But I did say that I want you to be able to identify isometrics of which trunk muscles are preventing the pelvis from spinning, thus the trunk from spinning. So that was also an isometric thing. Did I answer that? Sweet. Bless. It's that time of year where we're all getting the ick. Yeah.
These men out there, so like very.
Son tried to tell me the other day, I didn't understand the word. Kendrick. So I'm gonna go back home and be like, yeah, dude, I'm stuff. Yeah, yeah, yeah. Sounded fun. And then my wife like is all about like the royals. Like she gets all into like the royal family and stuff and all of them. Oh yeah, that's really interesting. But I'm sure my hobbies, they don't have Christine Hills. Golden Gibbons. I'm in a fantasy lumberjack league. And the season's going pretty good. You know, we draft lumberjacks and we get points and it's pretty fun. All right, nope. I want to take this as a teaching opportunity. So in other words, I don't want to just tell you answers because that's memorization. I want you to try. I want you to try to figure it out. I want you to try to practice. Remember, I've said this several times. I love this analogy. I could give you a book on soccer and you can memorize the book. Does that make you a soccer player? So this is a great opportunity to practice and to try to learn and to try to figure it out. So when you ask me to do an example, the expectation of that ask is that you engage in play and you attempt to answer it so that it makes sense and not memorize. It's through memorization that leads us into problems. I'll give you an example. Playing basketball, I used to drive by everybody when I was a kid. You know why? Because I was left-handed. They weren't expecting someone to go drive the lane on the left hand. I took them by surprise. 90% of people are driving with their right. They only use their right. Or left-handed pitcher we were talking about earlier, right? There's no natural lefty curve. Everybody's ball moves, but if 90% of people are right-handed, you get used to the 90 movement, to the right-handed movement, then all of a sudden a left-hander comes, you're expecting this, and that happens. And we as lefties get credit for all of this when it's not even there. So memorization can be a great tool, but it could also get you into trouble because we as humans pattern recognize. We pattern recognize up until we cut off the wrong leg, or we administer the wrong medicine, or we do the wrong treatment. That's why my first rule in class is do not assume. That doesn't mean you have to overthink. It's just stay with the process. Stay with the process. I'm not going to assume. I'm going to go with what I know. I'm going to look for the clues, and I'm going to try to figure it out. External force is trying to do what to the pelvis? Left transverse pelvis. However, what is gravity trying to do to the trunk? It's trying to twist the trunk to the okay. Let's go back and review. Left transverse pelvis. Did my trunk rotate? If my trunk didn't rotate, this is what would have happened. Did my trunk rotate? How did my trunk rotate? To the right. My sternum is looking at my right hip. And the only way that can happen is if I twist my trunk to the right. Clear? Sternum, looking at my right hip, I had to twist to the right. No different. This is the same as this. Looking at my right shoulder, looking at my right shoulder. All I'm doing is just taking this concept and dropping it down to here. This is the same as this from my trunk's perspective, cap and bottom. So gravity is trying to twist the trunk to the right. If you relax the legs, the pelvis does this, your sternum is going to be looking more at your right hip. Yes? Process of elimination. If gravity is trying to twist your trunk to the right, I don't need muscles that are trying to pull me to the right. Does that make sense? I need muscles that are trying to pull my trunk to the left. And those muscles are going to make you have left transverse as you come back to anatomical. And those muscles are going to let you have right transverse as you go from anatomical in that quadrant. If you flip the legs over to the other side, the exact same thing's happening with like the radiola joint. If I'm on comme ça, I need pronators. And if I'm over here, I need supinators. Right? It's a full range of motion. Supination, supination, supination. I need supinators. Supination, supination, supination. I need pronators. Because gravity's trying to supinate me here and it's trying to pronate me there. When I'm here, gravity's trying to twist my trunk to the right. But if I was here, gravity's trying to twist my trunk to the left.
Can you explain that? It's like, I don't think I've ever done this. Every time I'm bored by the building, I'm gonna try to turn in and like still continue.
That's why you have your arms out.
So gravity's trying to twist my trunk to the other side.
Gravity is trying to twist your trunk to your right.
It's trying to draw the picture. So you have the picture. It's trying to is that not the one? It's
For your pelvis. Okay. Let's go back. Does anybody have a... You're not the problem. You're not the problem. If I wanted to open this bottle, y'all think I have cough medicine in here? If I wanted to open, there's two motions here, open, close. Two motions, open, close. Most of the time, we say lefty loosey, righty tighty, because we're always usually going to move the small piece by the big piece. But I can open this by actually rotating the bottle righty loosey and lefty tighty, because the cap moving like this or the bottle moving like this gives me the same motion. Let's go to the cervical, but it's the same concept, it's just easier to see. Left transverse, cervical, left transverse, cervical. It's the same motion. It gets me to the same place. If I start here and I do this, and I say, hey, cervical, how would I have to move to go back to anatomical? Wouldn't I have to spin to the right to line my back? That means I had to move to the left. They're lined up, sternum and nose, they're not lined up. How would I have to move to go back? I'd have to right transverse. That means I had to have left when I moved from anatomical. Same exact concept. The fact that the sternum, do we agree that the sternum is facing the ceiling? The can't go with it because the arms are preventing it from going with it. And if you did go with it, you would do this.
Is gravity not trying to like?
That's why this stops us. You can try all at once. That's why our arms are out, so that we prevent it from happening. And our trunk muscles have an anchor to influence joint motion. Yeah, that would be a tough exercise to do like this. Feel that extra pull here, that extra push here. When I was at my mom's house, when I was sick, and all they had back then was like soap operas during the day. And when they would have an actor or actress who was out, they would have someone play their role. And they would say, the part of whatever is being played by the part of your legs, in this example, are being played by your arms. This is my feet. And I'm anchoring this so that I can rotate my pelvis about my trunk. This isn't easy, but that's why I'm not going to give you motion. And nothing worth understanding should be easy, because one, it's going to click. And you're going to have a certain tool in your toolkit as a young kinesiology professional that other students won't have. So what is preventing your upper body from going along for the ride? That arm. But we know that the sternum is facing the ceiling too. And gravity is trying to do this. And this arm is preventing the trunk from going along the ride. So gravity is trying to twist the to his right. Does that make sense? So if gravity is trying to twist the trunk to the right, I don't need muscles that are also trying to twist the trunk to the right. I need muscles that are trying to twist the trunk to the left. In fact, maybe this will make a little bit more sense. You have, in 415, I'm going to teach you about obliques. And I'm going to teach you about the left external and the right internal. I'm going to use some Star Wars references like Chewbacca's belt. The left external works with the right internal, pull in a direction of right transverse. And the right external and the left internal work together to pull in a direction of left transverse. So if you had to take a rope, attach it to the legs and pull so that the legs don't go down, wouldn't you want to use muscles that have obliquity like this? Right external oblique, left internal oblique. Those are left transverse. For the what?
Policy.
We don't have pelvic girdle rotators because it could be different muscle groups. I could have pelvic girdle. Remember, the pelvic girdle is like basketball. What spun it? That could be hands above, hands below. It could be because of my right hip muscles. It could be because of my left hip muscles. It could be because of my trunk. My elbow flexors are always the same muscles. My elbow extensors are always the same muscles. Pelvic girdle rotators could be different muscles. So we have to bring it back to what spun it. That's why I do it the way I do for the motion thing. Did we have pelvic girdle rotation? Yes. What was it? Yes. Okay, great. What was responsible for the pelvic girdle rotation? Oh, right hip internal, left hip external. Let's talk about those muscles. Those muscles spun the pelvis. The muscles of the trunk spun the pelvis. Does that make sense?
There's no agonist.
Was that?
There's no like agonist.
There's no agonist? Yeah, you would need left transverse trunk rotation. Because gravity's trying to twist the trunk to the right. It follows the same rules. It follows the same rules. What's gravity trying to do? Extend my elbows. What do I need? Elbow flexors. What's gravity trying to do to my trunk? Twist my trunk to the right. So I need muscles that are trying to twist my trunk to the left. Same rules. Our eyes are not used to seeing the cap and bottle stuff. It's the same rules. Our bodies are used to, it's not even our bodies. We're used to communicating motion the traditional way. It looks like it's moving and it is. We're not used to looking at motion like this, the illusionary motion. This is the illusionary way. Ah, you want to pause? You want to do some contraction? Yeah. It'd be the same muscle. If you're in this quadrant here, same muscles. But if you have the motion in the opposite direction of the pull, eccentric. If you have motion in the same direction of the pull, concentric. It follows the same exact rules. It's just harder maybe to, but again, just like anything else, practice and you get better at it. The more you practice, the better you get. It's hard not to want to go with the pelvis motion. It's hard. But we have pelvic girdle rotations, but the muscles that are spinning the basketball are either the ones above or the ones below. So we have to bring it back to either the hip muscles when our feet are on the ground or our trunk muscles when our feet are off the ground. In this case, we got to bring it to the trunk muscles. It would be eccentric if you lowered the legs down, which would be left transverse pelvic, but right transverse trunk. So if you lowered the legs down, left transverse trunk does right transverse motion through eccentrics. Same exact rules, just a little harder to see, but same rules. But remember, I'm not going to ask this question with motion. Yeah. It would be an isometric because that's enough for now. In 415, game on. Because in 415, we'll go through the specific muscles, and I think it helps to see those specific muscles to help better see what's happening as opposed to, standard. Five-minute warning, you guys. Let's get your money's worth. Again, Friday, if you choose, do your math. Do not ask me to do your math. It's not that I can't. I do math. It's that with my dyslexia, I don't want to be responsible by making a mistake. Like, it's your grade, it's your stuff, you do your math. If you want to take the cumulative final, I'll see you Friday. Not to take the final, but to go over, to review anything. Okay. That being said, I don't mind if you come into my office hours, we could do the math together. But like I said, you gotta understand, I have over 100-something students all asking me stuff. And it's not that it's a problem, I don't mind. I'm just terrified to make a mistake. I'm terrified to answer someone. And I thought it was this person, but it was that person. And then, it's all my fault. Question?
So for a stretching question,
Mm-hmm.
could it just be like a stone picture?
Yeah.
That's what's
Yeah,
specific.
I wouldn't ask a stretch question here. If I were to ask a stretch question, it would be where you would be at the range of motion. So I was like something like this. This is just an example. So at the top left, she's all the way twisted to her right. Her trunk is all the way twisted to her right. So she would be stretching muscles that pull back to the left. Does that make sense? Down here, her trunk would be all the way stretched to her left. So she would be stretching muscles that pull back to the right. And that's anything. If I want to stretch adduction pullers, I need to abduct my hip. If I want to stretch extension pullers, I need to flex my hip. If I want to stretch flexion pullers, I need to extend my hip. If I want to stretch internal rotation pullers, I need to externally rotate my shoulder. It's position, joint position, whatever that position is. Muscles that pull that way are going to get shorter as you move it that way, and muscles that pull the other way are going to get longer as you move that way. If I want to stretch left lateral cervical, I need to bend to the right. Stretch right by bending to the left. The twisting ones are the tough ones. If I want to stretch left transverse, I need to look to the right. But that also means this is stretching left transverse. Like that, if you can see the cervical, it's just lowering it down, but it's the same concept. That this is the same as this. So this is the same as this. I'd have to twist to the left to go back home. So I had to twist to the right when I left home. Good? On two, ready, break.